Yaskawa.
Welcome to this e-learning module introducing the A1000 AC drive and its features and benefits, brought to you by the Technical Training Department of Yaskawa America. Hi, my name is Paul Avery and I'm one of the Technical Training Engineers at Yaskawa America Incorporated. I will be your presenter for this e-learning module covering Yaskawa's A1000 Industrial AC drive. The A1000 comes in three different voltage classes, 240, 480, and 600 volts. The horsepower range of these A1000 differs by voltage class and is shown on this slide's graphic. Also shown are the normal duty amp ratings that correspond to the largest horsepower of each voltage class. Besides adding the 600 volt class, the A1000 will also reach larger horsepowers that were not available in the previous generation of Yaskawa industrial chassis drives. Yaskawa extends the A1000 power range by offering the A1000 drive in a modular high horsepower design. The A1000 HHP comes rated for two different voltage classes, 400 volt and 575/690 volt. By paralleling the modules, the A1000 HHP drive can source up to 2,250 normal duty amps. Yaskawa's high horsepower modular A1000 offering is comprised of two main components, a converter module and an inverter module. Up to 5 inverter modules can be run in parallel, fed by one converter module. If line regeneration is necessary, then the single non-regenerative converter can be switched out and replaced by individual regenerative converter modules, one for each inverter module in the drive. Because a different control board is used for the A1000 HHP design, the removable control terminal board feature normally associated with Yaskawa drives is unavailable. The figure at the bottom of the page displays the major components used in a non-regenerative 2,250 horsepower A1000 HHP. Though mostly unchanged from the previous generation of Yaskawa drives, the model number for the A1000 drive has changed in one major way. The model number now uses the drive's current rating to specify the relative size of the drive instead of the kilowatt rating of the drive. Since drives should be selected mainly by their output current rating instead of their output power, this is a step forward. As you will undoubtedly notice, Yaskawa has chosen to use the number 5 to indicate a drive with an input voltage rating of 600 volts AC. This merely refers to the fact that the drive is also rated for 575 volts. But make no mistake, as stated previously, this drive is rated up to 600 volts AC plus a 10% tolerance. Drive volume and the necessary cabinet size to install it in are the concern of all VFD users looking to enclose the drive. With the A1000 drive, Yaskawa has made the drive volume as small or smaller than their previous generation industrial drive. In some cases, the drive volume of the protected chassis A1000s are 50% or less than the equivalent F7 drive. This means a cost savings for drive installations. It is always an achievement to get the kind of versatility of usage that one associates with a Swiss Army knife. Well, with the A1000 drive, you get just that. Not only will the A1000 run all types of induction motors, but will also run permanent magnet motors. This ability to run permanent magnet motors extends to both the SPM or surface mount permanent magnet synchronous motors, but also IPM or interior permanent magnet synchronous motors. What it takes to properly control each of the different types of motor varies, but with Yaskawa, switching the drive to run a specific type of motor is controlled by a single parameter. Performance of permanent magnet motors will depend on the A1000 having accurate motor information. The auto-tuning function that has been available on Yaskawa drives for generations has been adapted to work for all motor types. The question to ask at this point is, what am I getting by using either type of permanent magnet synchronous motors? Well, let's consider each of them. First, the surface mount permanent magnet synchronous motor. The SPM motors are the smallest frame size of all three types we are considering here: induction motors, SPMs, and IPMs. They are extremely efficient and feature enclosures that do not require fans for cooling. IPMs are also smaller and more efficient than induction motors, but are usually larger than the equivalent SPM motor. They are capable of very high starting torque, even when no feedback is used. Also, when the proper drive controller is used with an IPM motor, open loop positioning is possible. Yaskawa exploits both of these IPM traits with the A1000 drive. The A1000 is not short on versatility. A single A1000 drive has 7 different methods for controlling the rotation of an AC motor. Each method has its own particular specifications and advantages. Use only enough control to get the job done. When only open-loop control is necessary, we have algorithms that can do the job and save on feedback device costs. If tighter motor control is required, the A1000 allows either closed-loop speed control or vector control, or both at once. We can even control permanent magnet motors in 3 different ways to allow for only using what is necessary for the application. One of the most exciting things about the A1000 is the capability to run an IPM motor at 0 RPMs while producing fully rated motor torque, all without any feedback device. This capability is derived from a powerful algorithm the A1000 uses to determine rotor rotation at low speed without the need for devices to sense pole position or some kind of encoder feedback. The end result is the A1000 user that uses an IPM motor without feedback can count on large amounts of torque over a 100-to-1 speed range. No variable frequency drive these days is complete without offering the user a way of optimizing energy usage, because we all know that the greater the energy savings, the lower the cost of operating your motor. Yaskawa does more than its green share by offering energy savings functionality in all 7 of the available control methods, and providing an auto-tuning routine that specifically optimizes the drive's ability to run the motor at its most efficient point. The graph at the right shows with the dark green line that when motor speed drops in certain types of applications, the motor efficiency starts to drop off as well. This is an opportunity to potentially decrease the operating cost of the motor by making the motor operate at a higher efficiency for the same speed. Using the Yaskawa energy savings function with an induction motor at half speed increases motor efficiency over 6.5%. The blue line on the graph shows that even greater energy efficiency can be expected from a permanent magnet motor used with the A1000's energy savings function. Let's take this even further because this is an important point. We can look forward to extra savings using permanent magnet motors. Using a typical fan application as a case study, and assuming some kind of kilowatt-hour cost, we can put a real number to the amount of money we will be saving yearly. On top of that, an even better savings will be seen in CO2 emissions, and that is good for everybody. Let's consider some more savings, but this time let's consider size savings. We have already mentioned that in the future we will be able to achieve a space savings for our motors by switching to permanent magnet synchronous motors. How much we may save was not mentioned, but in some cases permanent magnet motors are 60% smaller than the equivalent induction motor, more than enough to create interest in using the A1000 to drive a permanent magnet motor. Panel space and wall space are also a place where the A1000 will save. When multiple A1000s are mounted in a single space, a small current D-rate is the price of being able to shrink the space for the drives because they can now be mounted side by side. Removing the top plate, maintaining your ambient, and adjusting a single parameter are the only requirements after the installation, and then you're ready to run. A large part of what makes a drive user-friendly is found in how the user interacts with the drive programming. Yaskawa strives to make the A1000 easy to use and convenient by providing a full text-capable LCD keypad. The keypad comes standard on all A1000s and is not as an option like some competitors. Each and every A1000 keypad has memory built in that can be used to store the drive programming for use as a programming tool to move duplicate programming to similar drives, or as a programming backup that is easily removable from the drive. The keypad also uses soft keys marked F1 and F2 for functionality that can change depending on the current situation. The keypad can also display its text in one of 8 languages. All A1000s have a USB 2.0 port on the front of the drive directly below the keypad. This USB port allows devices such as personal computers to connect to the drive via a standard USB cable. This simplified connection technique allows either of the powerful pieces of software that Yaskawa offers for the A1000 to be run for extra programming capabilities. Underneath the keypad is the same RJ45 jack that was found on the previous Yaskawa drives, so any serial connection cables that we used on older Yaskawa drives for running Yaskawa software can still be used with the A1000. Auto-tuning takes a lot of the guesswork out of setting up a drive for running a particular motor or driving a certain application. The A1000 offers multiple ways to do both for either induction or PM motors. When optimizing the drive to gain optimal torque or minimum current, the A1000 has 4 different options. Rotational auto-tuning will run the motor and use the measured characteristics to enable the drive for best torque production and best speed control. When removing the motor from the load or application is not possible, Yaskawa's stationary auto-tuning routine will use advanced measurements and calculations to fill in what cannot be found through rotation. Lastly, for simple but important compensation for cable resistance or stator resistance, the line-to-line resistance tuning will do exactly that and no more. New to Yaskawa is the energy savings tuning, which will calculate exactly how to run the motor at its optimal efficiency at all times. Tuning to the load or application is just as important as tuning to the motor. Yaskawa offers routines that will analyze the load and help configure some hard-to-calculate parameters that are important for some of the A1000's more advanced functions to operate properly. Lastly, the automatic speed regulator, or ASR, is a function that keeps the motor speed exactly where it should be. The ASR can be optimized by running its auto-tuning routine. Even when the auto-tuning functions have been run and the drive is pushing the application, the A1000 will continually adjust the tuning to compensate for changing motor characteristics. Slowing down a driven load is always a potential pitfall to any application. Regenerated energy must be dealt with somehow. The A1000 offers multiple ways to help the user successfully slow down their application. The overexcitation deceleration function will increase the motor losses during any speed ramp down to negate the regenerated energy to the drive. During full stops of the load, high slip braking, another function for stopping, will optimize motor performance to limit regeneration and protect the bus from overvoltage. Both functions require no extra equipment such as braking modules or resistor grids, but can cut brake times in half when set and used properly. For applications that do require dynamic braking, all A1000s through 50 horsepower normal duty will offer built-in dynamic braking transistors. The user will only need to connect the properly sized resistors to achieve at least a 10% duty cycle dynamic braking circuit. One of the many yardsticks used to judge a new AC drive is the scan rate at which the drive operates. The A1000 features a 1 millisecond scan rate, which will translate into better dynamic response to application changes and faster reaction to changing analog and digital inputs. A faster scan rate can also contribute to an extremely low torque ripple at the motor shaft, which is necessary for applications like film lines and some extruders. Along with the lightning-fast scans, the A1000 also has a state-of-the-art function that modifies the PWM switching action to minimize current ripple. Lower current ripple and a faster ASR yields an almost ripple-less motor torque, as shown in the scope capture comparing the A1000 versus a previous generation of Yaskawa AC drive. Another technological first that will be part of the A1000's arsenal is the open-loop positioning capability that will be a feature of the A1000 when coupled with an IPM motor. Since this is open-loop, the need for a feedback source is unnecessary. Shaft position is determined by the electrical saliency property of the IPM's rotor. If you couple this open-loop positioning with the PLC-like programming capability of Yaskawa's DriveWorks EZ software, the A1000 will prove to be a low-cost and simple motion control device. The best way to demonstrate the ease of using the built-in DriveWorks EZ custom programming capability is to show it in action. If you press the play button in the lower left-hand corner of the video on this slide, it will show a custom program being created that uses 3 criteria for a run command. The 3 criteria are: the run command digital input must be closed, the drive must be in a ready state, and the frequency reference must be below 50% speed. Only then will the custom program allow the run command to become active. Another line of the programming latches the run, and the last added connection sets the AI analog input as the source of the frequency reference. After the program is compiled and loaded into the drive, the video will show the program put into the monitor mode and the program run while the status of each block is checked and the success of the overall program is verified. One of the biggest challenges to keeping any piece of equipment in appropriate working order is to figure out which components of the equipment may be nearing a point where maintenance is necessary. Well, the A1000 wants to help out with that problem. The A1000 has display monitors that are easily accessible that will tell the user how much of the expected lifetime of the cooling fans, output transistors, bus capacitors, or soft charge relay is still left. On top of that, the current heatsink temperature is also viewable, which is a good indication of just how hard the drive is working, and may also be an indication that the heatsink needs to be cleaned off. Even with the convenience of these maintenance monitors, it can be hard to remember when to check their status. Because of this fact, Yaskawa offers the option to program one of the A1000's digital outputs to turn on when a device is reaching a critical point of its expected lifetime. Speaking of maintenance, Yaskawa continues its trend of making the arduous task of maintaining any piece of equipment much easier when working with the Yaskawa product. On some drives, the heatsink fans are mounted on the bottom of the heatsink to keep them out of the stream of rising heated air. The problem being that when the time comes to replace the fan, any and all power and control wiring is directly in front of where the maintenance person wants to get to. With the A1000, the heatsink fans are mounted on top of the heatsink and far away from the wiring, thus simplifying maintenance. Despite the fact that the fan is now in the hot air stream, the expected lifetime of the heatsink fans of the A1000 has actually gone up when compared to previous generations, due to the fact that high-quality fans are utilized in the current design. Yaskawa AC drives have featured removable control wiring terminal boards for years. What is new in the new generation of drives like the A1000 is the fact that the removable terminal board now has memory of its own, and every time that a parameter is changed with the keypad, not only is it saved to the drive's control board, but it also gets saved by the terminal board. That means that the terminal board can be used to program other similar A1000 drives by simply plugging the terminal board into the target drive and uploading. As you might have already guessed, the removable terminal board also serves as backup to the drive's programming in case of problems, all without having to remember to do a thing to stay up to date with the programming backup. Not everything in the world of AC drive applications is planned on. Sometimes the unexpected happens, and a good drive will allow the user to handle the unexpected as well as it does the expected. One unexpected and unwelcome occurrence is the occasional loss of input power to the drive. The issue is that when power is lost, the motor goes into an uncontrolled coast to stop. The A1000 offers a function called Kinetic energy braking that will allow the drive to perform a controlled ramp to stop in place of the uncontrolled coast to stop. The A1000 will sense the loss of the input power by monitoring its own bus voltage. Once it is established that the line is gone, the KEB function will then begin to ramp the load down at a rate where regenerated energy from the load will keep the drive alive long enough to complete the controlled ramp. Now, with the inertia tuning auto-tuning function, the A1000 can optimize the KEB function by analyzing the load ahead of time. Not all industrial applications look the same to an AC drive. The A1000 has a selectable duty rating that is changeable with one parameter. As an example, the 23 amp version of the A1000, when configured for a normal duty application, like a fan or a pump, will be rated to provide enough continuous current to drive a 15-horse motor. If, however, the application is heavier, such as a conveyor or press, the 23 amp A1000 is rated at a lower horsepower, but will offer more overload capability. In essence, every A1000 drive is actually two drives in one skin. The upside is that the size of the drive is optimized for the application, which can save money. Yaskawa is and has always been interested in the safe application of all of its products. The A1000 is no exception and features built-in safety Category 3 circuits. There are two digital inputs, either of which will cause a hardware base block of the output of the drive. The functionality of this circuitry is TUV certified to the EN ISO 13849-1 and IEC 62061 certification. Because of the level of functionality maintained by the A1000, machine builders can integrate the hardware base block inputs and the safety circuit operation confirmation output as part of their machine safety sequencing. In many safety applications, the built-in circuit of the A1000 can replace some external safety contacts and thus saves money in the machine builder's design. The ability to integrate your AC drive with one of the many flavors of communication networks is a must these days. Yaskawa offers many communication options for your A1000 drive. Built into the A1000 is Modbus RTU protocol via the RS422-485 terminals, rated up to 115K baud, making it a powerful and low-cost option for serial communications. Beyond that, option boards offer communication possibilities such as DeviceNet with automatic device recovery, Profibus, Mechatrolink, and Ethernet IP and Modbus TCP IP. Meeting the correct standard is a necessity for panel builders and equipment users. The A1000 is UL listed for both Canada and the US and carries the CSA mark. The A1000 will also be appropriate for use throughout Europe and Australia since it meets CE and CTIC requirements. The A1000 also carries the TUV safety mark and uses all RoHS compliant materials. The A1000, as we have said, is a versatile AC drive. But to make it the answer to the maximum number of applications without bloating it with features that only certain applications need, the A1000 offers a deep list of optional add-ons. At the launch of the A1000 drive, many option boards will be available, such as the PGX3 line driver feedback card, the SI P3 Profibus card, and the SI EM3 Modbus TCP/IP Ethernet card. The A1000 has 3 serial ports rated at 1 megabaud on the control board for the connection of option boards. With 3 option board ports available, many combinations of installed option boards is possible, like 1 feedback card, 1 network card, and 1 option board for extra digital outputs. We discussed earlier how maintenance-friendly the A1000 is. Well, Yaskawa also strives to make the A1000 user-friendly as well. Using the USB or RJ45 jacks mentioned earlier, we can connect the drive to a computer and run the complementary DriveWizard software. DriveWizard will work as a setup wizard for the A1000, as a method for saving as many variations of drive programming as is necessary, and as a software solution for trending drive and motor information for future review. The current version of DriveWizard Industrial will always be found at the Yaskawa website. The A1000 lends itself to most applications, but it can be nice to associate some functions with an application that will benefit from them. A conveyor, for example, can benefit from the power of the custom programming offered by the DriveWorks EZ program to allow custom sequencing of driven conveyors without the need for a PLC. The fact that all A1000s offer both input and output pulse train capability makes coordinating between conveyor sections driven by different A1000s extremely straightforward. Over-excitation braking will be advantageous for the occasional fast stop without the need for expensive dynamic braking equipment. A typical mixing application can benefit from the A1000's ability to avoid nuisance trips from overheating and AC line imperfections, and has the optional ability to restart itself after certain faults, like too much bus voltage, to take it offline. The A1000 will also make integrating machine safety into your application simple and inexpensive. Finally, some extruder applications will be able to take advantage of the advanced open-loop vector for IPM motors control method of the A1000, due to the extruder using large amounts of torque near 0 RPM. Extruders also require rippleless torque during the extrusion operation so that the extrusion is consistent. The A1000's constantly adjusting PWM switching assures extremely low current ripple, which will lead to the low torque ripple necessary for the extruder application. Fan and pump applications are also beneficiaries of the versatility of the A1000's capabilities. The ability to set the drive for normal duty will allow the application to be run by a smaller frame-sized drive, which saves cost. All versions of the A1000 at and above 30 horsepower will feature built-in DC bus chokes to lower the input harmonics. The smaller A1000s will all have a simple connection for optional bus chokes, so that they can also limit the amount of input harmonics. The removable terminal board's built-in memory will help with programming and backing up multiple installations of identical pumps or fans. The preventive maintenance monitors tracking the already used estimated lifetime of major wear items of the drive will be a boon to maintenance personnel. Finally, the energy savings and space savings afforded by using PM motors with the A1000 will be a big benefit in the future. Let's summarize some of the things we know about Yaskawa America and have learned about the new A1000 industrial drive. Yaskawa continues to be the standard bearer for quality in their industry, as certified by independent third-party organizations. To see some of the numerous quality-based awards won by Yaskawa, feel free to follow the numerous quality awards link. With the A1000 drive, Yaskawa has given today's VFD users a winning product that is easy to set up and use, with features such as side-by-side mounting and removable control terminals with memory that automatically back up your drive programming. Maintaining the A1000 is also simplified through new keypad displays that show component wear and tear, as well as a new PC tool that will help with both setup and troubleshooting, and can be run via the USB port on the front of the drive. The A1000 harnesses the power of multiple processors and superfast scan times so that it can offer a 60 Hz speed response bandwidth and a quick torque response with low torque ripple so that your application throughput will be fast and accurate. The A1000 works with even more applications than ever because it offers 7 different control modes in both heavy and normal duty applications with 3 different voltage classes and with new larger than ever drive sizes. As we saw, Yaskawa has managed to do this while keeping the package size the same, or in most cases shrunk the volume of the drive. Yaskawa truly values savings. We help save energy, save your power costs, save space, and save the environment. We are aware of our environmental responsibilities, and we know our customers are too. Thanks again for joining me for another Yaskawa e-learning module. I hope that the time used to review this information was well spent. Please feel free to contact the Technical Training Services Group of Yaskawa America with any and all comments and questions. We would genuinely enjoy hearing from you. Thank you and have a great day.